polyatomics, and I'm going to include going both from name to compound and compound to name. So it's going to be really important for you is that you have your nomenclature formula packet out in front of you, and of course you always want a periodic table. So let's start with first going from name to compound. You want to make sure that you are always balancing your charges. And remember, these could either be two polyatomics, a type 1 in a polyatomic, a type 2 in a polyatomic, and even a nonmetal and a polyatomic. So let's start with the first example. I have silver cyanide. So this is the process that I would go through if I was having to answer these questions. So I'm going to start with silver. I know silver is Ag, and remember, we said silver will always be a +1 for us. Cyanide, however, is a polyatomic. So when I look for this on my formula packet, I get a carbon and a nitrogen, and collectively they have a negative bond. So as of right now, silver carries a +1, cyanide is its own charged group, and it carries a -1 charge. I have a +1 and a -1. I have equal but opposite charges. These are equal but opposite charges. And so I don't need to add any more silvers, and I don't need to add any more cyanides. So my final answer is silver, cyanide. And there's my compound. Moving on to ammonium oxide. Remember, ammonium, this right here is a polyatomic, and you get it straight off your polyatomic chart. So ammonium is always NH4 with a plus charge. Oxide, this ending right here reminds me that I'm dealing with a normal non-metal. Nothing special. This is not another polyatomic that ends in "ite" or "ate." If I see oxide, it means that it's just my normal anion, my normal non-metal. And so that means that it was oxygen. And so oxygen on the periodic table is always a 2- charge. So now I'm going to have to balance these out. I don't have equal but opposite charges. I have a +1 and I have a 2-. So I'm going to want to add another ammonium. So now collectively I have a +2 charge and I have a -2 charge. These are equal but opposite charges. So now I can write out how many atoms I have using my subscripts. So here's my ammonia, NH4. I want to make sure that I identify that I have 2 of them. So I'm going to put that in parentheses to organize it. So now I can clearly see that I have 2 ammonias because the ammonia is in the brackets, in the parentheses, and I only need 1 oxygen because that single lone oxygen has a 2- charge. So that means I'm just going to write NH4 parentheses 2 and then O for oxygen. And that's my final answer. Moving on to the other examples that we have, I'm going to go through one more naming, and then I'm going to do a couple of going from compound to name. So again, I'm dealing with ammonium. And for this particular example, I have NH4 is my ammonium. I have 2 polyatomics here because ammonium is a polyatomic and sulfate is a polyatomic. So I just get these off the nomenclature formula packet. Notice that my charges are not balanced. My ammonium has a +1 and my sulfate collectively has a 2-. I need to add another ammonium. And once I do that, I now have equal but opposite charges. Right here, I have a +2 charge. Each one of these is a +1. And over here, I collectively have a -2 charge. So that means that I needed 2 ammoniums, and that's how I signify that I have 2 of them. And I just need 1 sulfate. Sorry about that. I don't want to write the charge. So that right here is my final answer. Looking at going just from compound to name. Now you can identify copper is a metal from the periodic table. And remember, copper is a type 2 because it's not in the first or second family. It's not aluminum. It's not silver. And so this right here is a type 2 metal, which means I don't know the charge. So what I need to do is I need to use my anion, in this case my polyatomic, to help me balance everything to then figure out what is the charge on that copper. And so when I look at my nomenclature packet, if I find ClO3, I know that ClO3, because I'm getting this straight off the chart, ClO3 is chlorate. And ClO3 always has a -1 charge. But remember, I have 2 of them. So that means that right now, I really have this situation going on. So collectively, I have an overall -2 charge. To balance that copper, which I don't know what the charge is as of right now, I need that whole other side to be equal but opposite. So that means a +2 charge in order for my entire compound to be neutral. So that means that that single lone copper is a +2 charge. So now I can go back and I can say +2. And now I can use that 2 as my Roman numerals in the name. So I'm going to go to the name and I'm going to say copper. Two in Roman numerals because that's the charge for my copper. And then chlorate. And now I'm ready to move on to the last example. And hopefully this one looks a little familiar to you. I wanted to work this one out going backwards so you could get a hold of the balancing of the ions. So let's take a look. Immediately I recognize this as ammonium. And I know that each ammonium always has a +1 charge. And it tells me that I have 2 of them there. So right now I have this going on. I know that I need a 2 there because each oxygen always has a 2-. But this is easy to name because anytime that I'm dealing with a polyatomic, remember, for us, we're just taking the name off the chart. Oxygen is my nonmetal, so I just drop the gen ending, drop the Y, add the IDE. So this is ammonium oxide.